Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll continue this topical MCQ on my topic 2, which is atomic structure. So this is a 5-question tutorial series, and if you enjoyed the rest of what my channel has to offer, so do check other topical playlists out as well, and don't forget to click the button on the bottom right to subscribe to the channel and turn notification on to get all the latest updates regarding the channel. Or you can follow me at ptet.chemistry on Facebook, Instagram or Twitter if you use these social media platforms to get all the latest updates about my channel. So let's get started. So in this first multiple choice question, we have a compound containing the phosphide ion. So this is an ion, and they're asking us the composition of the phosphide ion, which is not the trickiest thing in the world. The number at the bottom left is called the proton number, or this is also defined as atomic number, which simply tells you the number of protons in the nucleus of an atom. The number on the top right, on the top left, top left, that is called the nucleon number, or also known as mass number. It simply tells you the total number of protons and neutrons in the nucleus of an atom, because nucleons refer to the particles in the nucleus of an atom, and those consist of protons and neutrons. All right, you have a 3 minus charge, so 3 minus charge means 3 more electrons than protons. That is a result of the atom gains 3 electrons. When you have atom, the number of protons equal to number of electrons, because atoms are uncharged, but ions are charged. That is because you started out from the equal number of protons and electrons, but you gain 3 extra electrons. That's why you get a 3 minus charge. That's why you become an anion, or what you call a negative ion. So starting off with protons, I will have 15 protons, not 17 or 32, because the number on the bottom left is 15. The electrons will not be 32 because I started from 15 electron if I'm the phosphorus atom, because equal number of proton and electrons will give me 15 electrons for the atom, but then I gain 3 electrons, so 15 plus 3 will give me 18 electrons. You gain electrons because you are negatively charged ion. The neutrons, on the other hand, neutrons will be the difference between the nucleon number and the proton number. Based on what I just said earlier, what nucleon number actually tells you the number of protons and the neutrons in the nucleus of an atom. So 32 minus 15 there, that'll give you 17. So A is the only possible answer there, and not B, because I checked the electrons before I checked the neutrons. This next question, so we have drinking water may contain dissolved calcium hydrogen carbonate. If you look at this stoichiometry, you will know that calcium is from group 2. So when they form compounds, you have calcium 2+, and as a result of it, you have 2 of these ions. So this must be HCO3 minus 2 times, because 2 times minus 1 is minus 2. Minus 2 cancel out the charge of 1 calcium 2+, and you also know that CO3 2 minus plus H plus will give you HCO3 minus, because carbonate 2 minus plus 1 give you minus 1. You get hydrogen carbonate. This is carbonate, this is proton. The two add together to give you hydrogen carbonate anion. How many electrons are present in a hydrogen carbonate anion? Start from proton number. Okay, so when you have HCO3 minus, you definitely know that in means 1. In one of these anion, how many electrons are there? We're going to start with the proton. Hydrogen has only 1 proton. Carbon has 6 proton. You have 3 oxygen. Each oxygen has 8 proton. So because you have 3, so it's 3 times 8, because it's 8 proton plus 8 proton plus 8 proton. So you have 24 proton. So altogether, you have 1 plus 6 plus 24, which is 31 proton. Okay, so for a neutral species, neutral meaning no charge, number of protons equal to number of electrons, therefore equal to 31 electrons. But minus 1 charge for HCO3 minus, so 1 plus 31, which is 32 electrons. Because minus 1 charge means you have gained 1 extra electron compared to the total number of protons. That's why you have a net negative charge. That's why you have 1 extra electron than the total number of protons, which you could calculate correctly by looking at proton or atomic number as given for free in the periodic table. They're asking for 1 hydrogen carbonate anion, not 2 of them. So there is 32 electrons there. So the answer is C there. Next question. So we have successive ionization energy, which means the first 7 ionization energy there. Between lithium and neon, this element is between lithium and neon, so this is a second period element. What is the outer electronic configuration of the element? We are looking for where the biggest jump is. From here to here is a give or take around 2k. So plus 2k, well, plus 2000. So these are not exact, these are approximate. And here to here is again around plus 2000. Here to here is around plus 2000. Here to here is around plus 3000, 4000. Here to here is plus 2000. Here to here, this is the biggest jump. You can definitely tell it's around 10,000 to 70,000. So there's around 60,000. Am I right? Yeah, okay. So definitely this is the biggest thing we are looking for. So if this is the first, second, third, fourth, fifth, sixth, and seventh, so the biggest jump, the biggest difference, or the biggest jump in ionization energy is between the 6th and the 7th ionization energy. So the 7th one is the sudden increase in it because we are removing from inner shell. And your inner shell must be closer to the nucleus. And when you are closer to the nucleus, when you are inner shell, that means you are less shielded because, well, closer to the nucleus, you are the inner shell, less shielded. It takes a lot more energy to remove the 7th one because there are only 6 valence electrons. So therefore, only 6 valence electrons. And you know that the number of valence electrons you have depends on your group number. So therefore, this is group, in the Roman numeral sense, this will be group 6. But in your A-level periodic table, they give you this Arabic numeral. So there's group 16. But group 6 like this or group 16 like that, they're going to have 6 outer shell configuration. Sorry, 6 valence electron. Not this because it's 2 plus 1 is 3. 2 plus 4 is 6. So C must be the answer. 2 plus 6 is 8. This is a noble gas configuration. A noble gas, that is a group 8. Or in your periodic table, they call it group 18. Okay. So in the next question, we are looking for the number of unpaired p orbital electrons. Very important. Unpaired p orbital electrons for atoms with proton number 13 to 18. 18 is argon. 11 is sodium. So this is aluminium. Okay, so you should know your first 20 elements actually. So aluminium is in group 13. Argon is in group 18. So this is 3 valence electrons. This is 8 valence electrons. But do not forget that this is the start of p block. So the p block starts from aluminium all the way to argon. The first element in the p block means you first fill in the p orbital, okay, from aluminium, because the first two, sodium and magnesium, they fill in the s orbital. They pair up and they fill those s orbital completely. Okay, so this is the end of the p orbital. So if I just do for all of them, aluminium, silicon, phosphorus, and then after group 5 is group 6, you have sulfur, you have chlorine, and you have argon, like that. So p orbitals, they are degenerate, meaning they have the same energy. There are 3 lots in one set. So the first electron like that, p1, p2, p3, and then you pair them up. This is Hans' second rule. Only after you maximize parallel spin, then you pair them up. This is fully filled third shell, sorry. So that means after the S2, the 3s2 gets filled in by sodium and magnesium, and then you will fill up aluminium all the way to argon with 6 more electrons. This is completely filled. There are no unpaired electron here, so no unpaired electrons in p orbital. That was what the question asked. Number of unpaired p orbital electrons. Unpaired p orbital electrons. There is 1 there. So 1 there. There's 2 there. There's 3 there. And then be careful. Unpaired. How many in the p orbitals are unpaired? So there are only 2 there. There's 1 there and there's none there. Okay. So we're looking at 1, 2, 3, 2, 1, 0. 1, 2, 3, 2, 1, 0. We're looking for 0 at 18. We're looking at 0 at 18, so that's wrong. We're looking at 0 for 18. We're looking at something that increase 1, 2, 3, and then 2, 1 again. This is increasing, so this is wrong because it doesn't decrease. Well, in fact, it's already wrong because it's not 0. It's not totally no unpaired electrons for argon. So that one is already wrong. This one, it doesn't have an increase at all. When we could see increase, there's no increase at all. So this bit is wrong because no increase. And I already said C was wrong. There's only one answer, even without me working out this thing. But of course, once you work this out, it's very easy to see why this answer. There's an increase, there's a decrease. It becomes 0 unpaired electrons because everything is paired up for element number 18, which is argon, noble gas. This is the last question of this 5-question series on atomic structure. We are looking for a group of particles in order of increasing size, bigger in size. Alright, so a lot of it comes down to effective nuclear charge, which of course depends on nuclear charge. And nuclear charge, the only nucleon that is charged, that means it depends on the number of protons. And then we're looking at shielding effect as well. So the net effect between the nuclear charge and shielding effect will give you this thing called effective nuclear charge. I'm not sure if this has been taught in your school or not, but I've always taught in terms of effective nuclear charge being the balance of this nuclear charge as well as the shielding effect. If we look at option A, very quickly look at proton and electron, 7, 8, 9. These are atoms. For atoms, number of protons equal to number of electrons because atoms are electrically neutral. And by looking at this, we know that going that way, the Z effective essentially increases because you're filling in the same subshell. You're filling in the same shell, sorry, not the same shell. You're filling in the same orbital, the same p orbital. So the shielding is roughly the same, but you have increase in protons, and therefore they will attract the electrons more and more. So the size would decrease. So fluorine is smaller in size than oxygen than nitrogen. And these are given for free in your data booklet, by the way. They give you the size, which of course you can get the trend by comparing these very, very easily. So they don't increase in size, they decrease in size going in that order. For B, I have N3 minus, O2 minus, and F minus. So proton, electron, 7, 8, 9. So it's 10, 10, 10. They are what we call isoelectronic because they all have the noble gas configuration of neon. As you could see, the number of proton increases, but same total number of electron. So we are talking about the nuclear charge increasing, but you have the same shielding effect because you only fill up to the second shell completely. So the 2s and the 2p are completely filled. The shielding is roughly constant, but the proton consistently increase in number. So your attraction between the protons and the electrons, which are the same number, would get stronger so your Z effective gets stronger, and again your size would decrease. And if you know anything about general periodicity, you will know about atomic radius and ionic radius. So generally speaking, the atomic radius decreases across a period, so sodium to chlorine, and then we have the cations being smaller than the parent atom, and then the anions being bigger than the parent atom. Okay, as a result of comparing these things, so the anions are bigger than the parent atom, but the anions are also decreasing in size. We're looking for increasing in size, so B is definitely wrong as well. So judging by that, the cations are also decreasing in size. So we have Na plus, Mg2 plus, Al3 plus. So the cations are decreasing in size as well. So C is also wrong. D must be the answer because none of the others are correct. I will very quickly show you how we get this trend now. So Na plus, Mg2 plus, Al3 plus. Compare proton and electrons, 11, 12, and 13. These are isoelectronic again. They lost 1 electron, they lost 2 electrons, they lost 3 electrons. They're all neons configuration. For the same number of electrons, your nuclear charge increases, your shielding is roughly constant because you only fill up to the second shells and they have the same total number of electrons, so they fill up to the exact same second shell, the exact same orbital, the p orbitals get completely filled up. Okay, so effective nuclear charge increases, therefore size decrease. That's why we get this trend here, the anion just now. That's why we get this trend here. That's why we know B and C are wrong, because they will be decreasing in size in that series from Na plus to Ne to F minus, Na plus to Ne to F minus, Na plus to Ne to F minus. Again, compare protons and also electrons. 11 protons, 10 protons, 9 protons. So it seems that we are going backward now. This is 10, 10, and 10. So just now, we said for the same total number of electrons, as we increase the number of protons, the effective nuclear charge increase this way. So the size gets smaller this way because the attraction gets stronger, so the size gets smaller. When you go this way, then the size will get bigger because the effective nuclear charge gets smaller because you have smaller nuclear charge that way. All right, so that's why the answer is D then. So that marks the end of these 5 question series on atomic structure. So if you have enjoyed these topical MCQs on my channel, they are actually pretty good in my opinion for revising your AS theory because they actually test a lot of things. I actually go through a lot of concepts rather than just getting to the answer itself. For me, I personally enjoy doing a lot of MCQs because they actually a source of inspiration, and by doing quite a lot of them, they actually help you to revise the whole topic rather than just focusing on the structured questions, which are only testing you on one thing, whereas you should be revising the whole syllabus. And MCQ provide you better opportunities to actually explore the whole syllabus by knowing what is right and what is wrong. Okay, so don't forget to subscribe to my channel and share the channel widely with all your friends, your study groups, your chat group, your social network. And I appreciate you sharing the network, and I think it will help a lot more people if you share all this good stuff. And let me know if you spot any mistakes in my work. As usual, I haven't really gone through my work, so if you spot any mistake, let me know. And you should always check through your work when you're done. Leave a few minutes to, some time to check through your work because there are bound to be mistakes here and there if you are not careful like me. Alright, so yeah, I'll see you in the next video. Thank you for watching.